Hi, welcome to Famar. Famar is located at the foot of the Alps, just to the west of Torino, the first capital of Italy. The company is situated just below a beautiful abbey that's sitting on the top of one of the mountains in front of us. And the abbey was built in 986 AD, the Sacra di San Michele, an abbey that is still standing today, and we use it as our symbol because it shows the hard workmanship and the tenacity of the people that work in the region. So come, let me show you Famar, where the magic happens. Come. Famar is part of a larger group, Famar Group, in which we have 5 different companies. We have Famar for inverted vertical lathes, we have Fausto Marinello for single and double spindle horizontal machining centers. We then have Famar Automations, which is part of Famar, that make automatic feeding solutions for our machines, but also directly to customers, so helping customers with their needs of automation. We then have 2 offices, one in Germany and one in China, that take care of our sales and service in the respective companies. And then in the US, we have a partner called Select Production, a part of Morris Group, that take care of our sales and service in the US. Buongiorno.
Buongiorno.
So here we have our technical department, divided into 3 sectors. Where we do all the applications. We have all our applications engineers. On the right we have the automations and our standard machine, so bed frame, spindle and turret design. And we have our project managers, project management. We then have our systems engineers, so electrical, hydraulic and pneumatics, where all the design is done. We also have space for our programmers to program offline PLCs and CNCs. In Famar Group, all our machines are made 100% in Famar, inside, internally. We have machines making machines. We have a number of machining centers where we machine all our bed frames. We receive the bed frames from a supplier. They get welded by the supplier and normalized. They then arrive here. We then machine them on these 2 large machining centers, completely in 2 phases. Once they're finished, they go for painting, filling with polymeric cement and assembly. Apart from these 2 large machines, we have a number of smaller machines where we are machining all the components that go into our machines. So all the components for our main spindles, all the components for our turrets are completely made 100% in Famar, so that we have very good control over the production process of our machines, and we're able to intervene in a timely manner if there is any issue or if we require any modification. Once the electro-welded steel bed frame has been machined, it arrives here, where it gets flipped 180 degrees. We fill it then with a special polymeric cement that gives the machine weight. So a sturdy machine, very stable for the machining process. It gives the machine also vibration dampening, thanks to the polymer that's inside the cement, but also thermal stability, due to the fact that the steel and the cement have the same dilation coefficient. So during the machining process, when the machine obviously heats up, it's going to not have a detachment between the cement and the steel, causing then vibrations in the steel. Once the cement has been dried, we let it cure for a couple of weeks. It then gets painted into these stations here, where we paint them either to customer specific colors or to our own standard coloring. For example, this bed frame here, which is painted to our standard color, it gets taken over to one of the assembly positions in one of our assembly halls. Here we build our spindles. All our spindles are built in-house, and also our turrets. So here is where we assemble completely the entire spindle for both Famar and Fausto Marinello. We receive the shaft from a supplier. It's our own design, machined by our supplier. We then install the bearing sets. We install the rotor on the main shaft. We install also, then we put it all together with the main housing and the stator. We install the rotary encoder for C-axis positioning on the main spindle, and then it then goes for testing once it's complete. Once the main spindle has been completely tested, it goes for painting. Our standard color is this yellow over here, and then it gets mounted together with the X-axis carriage. The main spindle housing over here is mounted on our standard spindle configuration. We have 2 guideways over here for the Z-axis. Each guideway has 2 trucks, so in total we have 4. Now the position of the guideways is positioned very central. So if you draw a line that joins them, it passes exactly through the center of the Z-axis over here. The same will go for the X-axis housing. If I look at the trucks, we have 4 trucks. We'll have 1, 2. We'll have a closing element which will come on top here and join to close off the housing, and we'll have 3 and 4 trucks. Now if we draw the diagonals, they will meet exactly in the center of the Z-axis, so making it a very central and stable system. All our axes are ball screw driven. Over here the ball screw will run and move the X-axis back and forth, left and right, and then the Z-axis is on the back that will allow the spindle to move back and forth. We also have a second configuration for the main spindle, which is called the ram configuration, which we see over here. Now the ram configuration is slightly different compared to the standard spindle. It's configured as a ram. So instead of having the trucks mounted onto the main spindle and the guideways onto the X-axis housing, it's inverted. We have 4 guideways. So instead of having 2, we have 4 guideways that will be positioned here. On the housing, we will install the trucks. So we have 2 trucks per guideway, so in total 8 installed in the machine. And then the guideways are installed on the main spindle like you see over here. So we have 1, 2, 3 and 4 guideways. Those guideways will be positioned inside here, making it a much more rigid and strong structure. So once that is completed, it will be installed here together with the main spindle housing. Again, it will be ball screw driven in the Z-axis as well as in the X-axis. This system allows for more rigidity, so especially for that tough machining where we are machining very strong cast irons, or there's a lot of stock material, this is an ideal configuration for that hard machining or that tough machining. Here we see a size 500 spindle carriage, completely finished, ready to be installed onto the machine. So the configuration would be this. We have the main spindle over here with its 2 guideways. In this case, we also have a linear scale in the Z-axis. It's an option on all our machines. It is standard on the X-axis. Here we have the 2 counterbalancing cylinders. All our spindles are counterbalanced through hydraulic cylinders that you see over here, mounted on the main spindle. At the back here is the motor for the ball screw, for the Z-axis movement. Again, the X-axis would then run through the back here. Now from a spindle size, this would be a size 500. We have spindles that range from a size 120 millimeter spindle, which is the smallest spindle we install on the inverted vertical lathe, and we go up to 1250 millimeter spindle, which is the largest. They're the range in between 160, 200, 260, 400, 500, 815 and 1250. Each machine also has the possibility of having a power motor, which we distinguish with a separate number to determine if it's a standard spindle or a power spindle. Once this is complete, it's going to go and be installed on the machine. In this area, we also, apart from the spindles, we also build our turrets. Both fixed and live tool turrets are all completely assembled here in this facility. Our live tool turret, completely built in Famar, has extraordinary characteristics when it comes to speed, power and torque, thanks to the fact that we don't have any sort of transmission system that runs through the turret and brings the drive to the live tool. We have a motor directly positioned in the tool disc that gives us direct drive to the live tool. So on this size turret, which is a size 40, allows us to achieve 10,000 RPMs, 88 Newton meters torque and 12.5 kilowatts of power. So an extremely strong turret in the machine. We also have a larger turret for the larger machines, which is a size 50 turret that has 8,000 RPMs, 22.4 kilowatts of power and up to 145 Newton meters maximum torque. From a tool interface, our turrets come with a standard VDI 40 or VDI 50 interface, depending on the size of the machine. We also have other options which allow you to integrate either Capto, HSK or KM tools directly in the tool disc. This is where we prepare all the electrical cabinets of our machines. So we do the complete cabling of the electrical cabinet. We have all the modules and units that will go into the electrical cabinet. We install them, we do all the offline cabling of the electrical cabinet, and then once it's complete, it will go to the assembly position inside our assembly halls together with the bed frame of the machine. Here, where we assemble all our hydraulic and pneumatic units. So we do the complete assembly again offline. Once it's completed, we do also all the piping Once that's completed, it will go and be assembled together with the machine at one of the assembly positions. So as you can see here, we're busy preparing a number of various units that will then go to the dedicated machines. Also, all our main carriages, together with the X-axis, once they have been assembled, arrive here where we do the final cabling and piping. So as you can see, we have at the moment 2 carriages here, one for an ergo or tandem 200, and instead over here a 500 version. So once the cabling here is complete, all the piping is complete, it will go and be mounted together with the machine. Our tool room, where tools can be preset for pre-acceptances and machining. We then also have various metrology rooms in all our facilities. This is number 1 of 5 metrology rooms that we have, where we do all the capability runs. Once the run has been completed on the machine, the parts come here. We have them measured. CMK evaluations are done and supplied to the customer. We also measure parts that go into our machines. So here we would also measure a part that we've manufactured in our production area, in our production, and we would measure it to make sure that it's conform and to tolerance. Here we are in Famar Automations, where all our automation solutions are assembled. So we do an initial assembly here. Once it's completely assembled, it'll go to an assembly position inside our main hall. Here we pre-assemble all the conveying systems. The conveyors are our own conveyors. We have our own aluminum extrusions that are made by a supplier of ours. It then all gets assembled here and then goes to the machines for testing, as well as not only conveyors but feeding systems, etc. will be pre-assembled here. So we're just walking through here our warehouse. We stock over 2 million euros worth of spare parts here for our machines. We have here an Ergo 260G. Ergo meaning single spindle machine. 260 diameter of the main spindle in millimeters, and G indicates grinding. In this case, we're doing an ID grinding on transmission gears. The machine has an A6 spindle nose. It has 5,300 RPMs, 31 kilowatts of power maximum, and 196 Newton meters torque. So a very powerful machine. If we look at the machine, we have the machining area over here. That is a completely closed off chamber. We have an intermediate door that will shut during the machining cycle. During the loading and unloading cycle, the door is going to open, allow the spindle to go out into the loading and unloading area, where it will clamp apart and move into the machine. We have, in this case on this machine, we have a Siemens 840D solution line control that controls all the axes of the machine. We have X moving across from right to left from the operator position, and inside we will have the Z axis moving up and down. From an automation point of view, this specific machine is in a standard setup. So we have a pallet conveyor for loading parts, where the operator would load all his raw parts. We then have the secondary unloading line, where the spindle will unload a finished part. It will move along this conveyor and buffer onto this unloading table. Here we have an Ergo 500 machine. The Ergo 500 has an A11 spindle nose. It has 780 Newton meters torque on the main spindle and about 36 kilowatts of power with 3,200 RPMs. This specific machine has a slightly more complex automation. Compared to the standard machine setup, we have integrated a robot cell that will take parts from a trolley system, where parts are stacked on trolleys. The robot will collect the part from the trolley, load the shuttle system that you see behind me here. The shuttle system is going to go into the machine, load the machine, unload the finished part, take it back into the robot cell, where the robot will flip it over 180 degrees for the second operation. The same machine is going to do also operation 20. So it's going to go back in, the spindle is going to load this operation 20, machine operation 20, and then take it back out to the robot cell. The robot here, we have again another example of how much we can integrate processes. In this case, we have a line of 7 machines machining truck wheel hubs for a large customer of ours in Sweden who bought 3 lines. identical to this one. We are in the assembly phase of the lines. In this case, we have 7 Ergo 500 machines machining the truck hubs with a pallet conveyor that runs through all the machines and brings the pallets back in on the return side of the pallet conveyor. Each machine is identical machines. The line is made up of Ergo 500s, as I said, the Ergo 500 single spindle machine with a diameter 500 millimeter spindle, an A11-inch spindle nose. We also have 3,200 RPMs, 36 kilowatts of power on the main spindle with about 780 Newton meters torque. The main spindle completely built in Famar. In this case, we have a number of Ergo 500s, but we also have 3 Ergo 500 2T machines, so with a double turret. The double turret allowing to change the pitch between the two turrets, allowing to machine various different hole sizes at different pitches with our live tool turrets. Also, our live tool turret is built completely in Famar. On these machines, the live tool turrets have up to 8,000 RPMs. We have 22.4 kilowatts of power and 145 Newton meters torque on the live tool. The line is completely integrated. It will be integrated with a loading cell in the front and an unloading cell at the back, 2 robotic cells that will feed the parts onto the line. The line will then obviously convey all the parts through each machine to each operation. Now this machine is a detail of one of the machines of the line. In this case, it's a double turret machine, as you can see over here. We have one turret that is flanged directly to the bed frame, so it's in a fixed position. The other turret is mounted on an additional X1 axis, so it can move and change the pitch between the two turrets. So we do drilling and tapping of 2 holes at the same time, as well as milling operations or drilling operations. All right, well, all I can say is thank you. Thank you for taking the tour with me to see Famar and Famar Group. I hope you enjoyed it, and I hope to see you soon. Ciao.